Today we're going to talk about cognitive and perceptual development from 0 to 3. And I'm going to focus on 3 themes just as examples of areas of cognitive development that are changing in the young child. Attention, memory, and understanding of the physical world, number and magnitude, and vision and perception. Let's think about attention. As children are growing their motor skills, they are able to pick up objects and look at them and explore them and learn about their worlds more broadly, learn about the people in their environments and the objects that inhabit the environment. Through this process of attention, memory, and acting on the world, babies learn quite a lot about the features of objects and how to communicate with others. Observation and play are in fact the work of infancy, and infants spend half of their time just manipulating objects and wandering around their environments, seeking out things to explore. Now, one of the first researchers to examine babies' actions on the world was Jean Piaget. Jean Piaget was a theorist who talked about the way children construct an understanding of the environments around them. And he was a stage theorist, so he felt we move through different stages of development. And in the infancy period, from 0 to about 18 months to 2 years of age, babies are in what Piaget referred to as the sensory motor period of development. And what that means is they're learning by their senses and they're learning by motor, acting on their worlds. And what Piaget said is at this period, from birth to about 18 months, babies are unable to symbolically or mentally represent their worlds. And it was the achievement of mental representation around 18 months to 2 years of age that actually signals the culmination of the sensory motor period. It means babies are now moving into the next period of development. And how we know that they've achieved mental representation, according to Piaget, is the use of language as a symbol system to refer to the world, and also pretend play. And another aspect of mental representation is the achievement of object permanence. And that's the idea that an object continues to exist even if you can't see it. So Piaget would hide toys under pillows and shift those around, and then look at whether the baby would search. If the object's not under pillow A, would it be under pillow B? And he found it was not until 18 months, 2 years of age, once more, that children would regularly search multiple places, understanding or reasoning that the object still existed even though they could not see it. But there's been a lot of challenge to Piaget's ideas about infant capacity. In fact, new methods have lent new insights and challenged the view of an ignorant baby. So, for example, using new methods, we know that babies can learn or know not just that objects continue to exist if you mask them or hide them, but also that objects need support, otherwise they'll fall to the ground, and objects can't move through space if there's another object occluding the path, and so forth. They can even reason about numbers, as we will see. So how do developmental scientists know that babies could understand these concepts at younger ages than Piaget showed? Well, it's based on a universal tendency among babies that babies will look longer at a novel event than a familiar event. They're curious. They want to learn about something that's odd to them or different to them or complex. By using this tendency to visually orient toward the novel, we can ask, how early is it that babies understand the difference between an impossible physical event and a possible one? René Bellerjean is someone who did work in this area and showed that babies actually achieve object permanence at much younger ages than Piaget asserted. Here's an example of one of René Bellerjean's studies, which looked at the notion of support, that objects will fall to the ground if not supported. At the top panel, you'll see this is a possible event. Imagine that there's a block on top of a support landing, and the examiner pushes that block to the end of the landing, but still it's being supported by the long block underneath. That is something possible. But imagine if the examiner pushed the block over past the landing where the object normally should fall to the ground. That's impossible for it to kind of float and dangle in air. And in fact, babies look longer to the impossible event than to the possible event, suggesting that they might be recognizing the odd features of this object hanging over space. And those are some of the ways that we now look at what children understand about their worlds. Using the same kind of paradigm, examiners have also asked questions about, do babies know anything about number and math and so forth? Karen Wynn designed an experiment that has been cited quite a lot that suggests that babies can do simple math in a very rudimentary way. How did she do this? Let's consider a 1 plus 1 problem. On the top panel, you'll see, imagine that a baby's watching this panel, and then there's a little doll that's pushed along the screen, and it's a kind of a Mickey Mouse sort of doll. And then a screen comes up and blocks the Mickey Mouse. Then the examiner brings another Mickey Mouse behind the screen. So the baby can't see anything behind the screen, but in their head, 1 plus 1 should equal 2. When the screen is then lowered and there are 2 dolls there, that's a possible event. The baby doesn't look that long. But if you lower the screen alternatively, and there's only 1 Mickey there, even though a second one had been introduced, the babies look a lot longer, as though they realize 1 plus 1 equal 2, 1 plus 1 does not equal 1. We see that infants are perceiving their worlds and thinking about their worlds and reasoning as we look at these new methods. They also are expressing themselves and using their thinking to communicate with others. For example, even before babies can talk, they use gesture to show what they're thinking by kind of going like that for drinking a cup and so forth. In fact, researchers have used the propensity toward gesture as a possible way to intervene and promote language development. So researchers have engaged in an intervention called baby signs, where they taught babies kind of a vocabulary of gestures like more, drink, and so forth. And after they taught these babies these gestures, these were pre-linguistic children, when it was time to enter into language, they actually talked earlier than did babies who were not in this intervention. We see that expressing yourself communicatively, cognitively, is one way to segue into the world of language, which we will cover next. The reason gesture might appear before language is those sensory regions of the brain of vision are developing earlier than are those language regions of the brain, and earlier than the cognitive regions of the brain. We also have looked at what babies prefer to look at and attend to, and one of the things that has been of high relevance to caregivers is the fact that babies prefer to look at faces than other geometric stimuli. In fact, we know that if you take a normal upright face and then you scramble the features and show the face upside down or in other orientations or scrambled, that babies actually prefer to look at the normal upright face because all the regions of interest are on the top of that visual, and that kind of attentional bias paves the way for growing an attachment with one's caregiver and learning about faces and communicating and socializing with other people. So let me summarize what we know about cognitive and perceptual development in a couple of examples that I provided. First, infants are observing and acting and testing the world, and they're little scientists. They're constantly engaged with the people, the objects around them. They have strong perceptual biases. For example, they prefer to look at human faces, which might wire them or help them bias towards social interactions as well as learning language. So they are mini scientists. They're testing hypotheses, how objects operate, how categories such as number are determined, and they begin to learn that they can communicate with other people through gestures.